Hello guys, hope you all are doing well. Welcome to my channel Accidental Teacher. Don't forget to subscribe it. Today in this video we are going to do some number programs. Hello friends, welcome to my channel Accidental Teacher. Today we are going to start off with a new topic that is known as number programs. First, I'll be discussing about few techniques how to solve the number program, and then we'll do some programs as well. So let's start. The first topic that we are going to discuss is breaking a number. So first let us understand a little bit about what do you mean by breaking a number. So I'll take one example. Let us take an example 175. So it's a number 175. So breaking a number means to break, to get individual digits. So we are getting 5, 7 and 1 separately. So that is what is breaking a number. And on those numbers, several operations are carried out. So first of all, today we are going to learn how to break a number. So how to generate individual digit. So for that, I am using two variables n and r. Both the variables are of type integer. So n, I have written over here, it's the number given by the user. So n is a number which has to be used in the program to search whether it's a even number, near number, or it can be like different kind of program as well. So n is a number given by the user. And r will take a variable r, integer type variable, to store the value of remainder. So we need remainder over here. So later on you'll understand why do we need. For the time being, just understand r is also integer type variable where we get the remainder of something. So let's find out what we are going to get, what remainder we are going to get. And I have written a code over here using a while loop, and I have also used the dry run. So I'll be explaining it with the help of dry run. And by now I hope you all know what is dry run. Dry run is the program I have done in a piece of paper with the help of pen if you don't have a computer. But we are going to do this on the whiteboard, okay, using a black marker. So over here in the loop, the first thing, while n is greater than 0. So this is the condition we are going to use. One more condition we can use over here is n is not equal to 0. So you can use either of the condition, either n is greater than 0 or n is not equal to 0, because after the loop is over, the value of n always becomes 0. So that is the reason why we can use either n is greater than 0 or n is not equal to 0. So it's up to you, whatever you want to use. Inside the body of the loop, you can see two lines of code over here, and I have made a rectangular box. I'll be explaining it step by step. The first thing, r equals to n modulus 10. So in this statement, what we are trying to do is, we are trying to get the remainder. When we divide a number n with 10, whatever is the remainder, that will be stored inside r. Now if you think logically, whenever we divide a number by 10, the remainder will be always the unit place. Like suppose the number is 213 modulus 10. Remainder is always the last digit, that is 3. Suppose you divide a number 1852 modulus 10. That means the remainder is 2. So we are finding the remainder when a number n is divided by 10. And how it is useful in our program, that also I will show you when we are doing the dry run. Next thing what we are doing is n equals to n divided by 10. So you are dividing the value of n by 10 so that one digit gets removed. Suppose a number is 213 divided by 10 will be 21. Now some of you may be thinking the answer will be 21.3, which is correct. But I have already told you the variable n will be of type integer, and integer does not understand anything after the decimal point. So over here 213 divided by 10 will be 21. So that is the reason why we are using integer for remainder as well as n. So it's very important to use integer. If you use double, the program is not going to work. Now these two things is done in most of the number programs. So this two logic is used in most. I didn't tell you all, but in most. So first we are doing this type of program, number programs, where remainder and breaking a number rule is implemented. And the program will be different, so the difference will be over here. this part of the program will be same for those type of number programs, but the difference will be over here. So that will be understanding when we start with the examples. Now let's see, when we are using this technique, what happens in the memory space. So for that, we'll take one example. Let's take a number like 1785. So 1785 is the number we have taken. Now what we will do is we'll break this. So we'll break this into 4 parts. So we'll have 5 separate, 8 separate, 7 separate and 1 separate. So let's see how we can do that. So we have the first condition, either of the condition we can use. So n is greater than 0. So obviously n is greater than 0. So it will go inside the body of while loop. R equals to n modulus 10. So 1785 modulus 10. Now for this we don't need rough work, because I have already told you, whenever you divide a number by 10, the answer is going to be the number that is there in the unit place. So the last digit. So here 1785 modulus 10 will be 5. So the value of R over here is 5. Next we have n equals to n divided by 10. So 1785 divided by 10 will be 178. So this value is not anymore stored in the variable n. So the new value is 178. As I have told you, n is an integer, so that's why we don't have a decimal point. After that, whatever is the program about, we are going to do that, and then again we go back to the loop. We check the condition again. Now 178 is greater than 0. Obviously it's greater than 0. Again we are coming down over here. The value of R was 5. Now n modulus 10. Now the value of n is 178. So 178 modulus 10 is going to be 8. So temporarily the value of R was 5. Now it became 8. So I understand we are fetching the digit, like we got 5, then we got 8. Now let's see what we are getting next. Now n equals to n divided by 10. So 178 divided by 10 is going to be 17. So 178 is no more the value of n. The new value is 17. Again we are doing some work over here depending on the program. We are going up again over here in the while loop. Again n is greater than 0. Condition is true because 17 is greater than 0. Again we are coming to the remainder. R equals to n means 17 modulus 10. So 17 modulus 10 is 7. So 8 is no more the value. Now we have 7. Then we have n equals to n divided by 10. So if we divide 17 by 10, what do we get? We get 1. So 17 is no more the value. Again we are going up. Now see, the value of n is 1. 1 is greater than 0. So 1 is greater than 0. We are true again. Again we come down. Now a very interesting thing. Remainder equals to 1 divided by 10. So whenever we have 1 modulus 10 over here, the value of R will be 1. Now some of you are confused with this one. How 1 divided by 10 is 1, the remainder is 1. It's very simple. I'll just do it over here. The number is 1 and you are dividing it by 10. So 10, 0 times 0. So the remainder is 1. So this way we are getting the value of remainder. Now after that, n equals to n divided by 10. So 1 divided by 10. 1 divided by 10 means 0 point something. Now as I have already told you, decimal point we are not going to use because the variable n is an integer. So what we will do, we will just take the integer part. So the integer part is 0. So 1 is no more the value of n, the new value is 0. Now we are going back to the loop again. 0 is greater than 0 or 0 is not equal to 0. Both the condition over here is false and the loop is over. So this is how we do the program. Now over here, if you notice, the variable R is 5, 8, 7, 1. So did you see how we broke the number over here? So the variable R contains 5, then 8, then 7, then 1. And this can be used to maybe add sum of digits, multiply sum of digits and so on. So this way we we can do the number programs which is related to breaking a number. Now let's start with the first program over here. As you already know how to break a number, so we are going to do series of programs which are based on that technique. So before starting a number program, the first very important thing is to understand the program. Understanding the program very important for number programs. The program over here is to find the sum of digits. So what do you mean by finding the sum of digits? So let's check that. So over here I have taken one example, 731. You have to understand the example for every number program, because in your exam, ICSE, IAC, whatever, or CBSE or any other exam also, the examples will be given. So you have to check the example very carefully. So the number is 731. So sum of digit means 1 is also a digit, 3 is a digit, and 7 is also a digit. So you have to add all the digits over here. So 7 plus 3 plus 1 is 11. So answer for the sum of digits of a number 731 is 11. So that is what we are going to do in the program. By now you know how to break a number. So you know how to get numbers like 1, 3 and 7 with the help of modulus. So we are going to use R, because we know in the variable R what is going to get stored is the digits 1 by 1. So looking at the program, first thing I have taken integer R to find the remainder, N to get a number from the user, and S to calculate the sum of digits. So S equals to 0. We have taken S equals to 0 because you know whenever we are adding something, 0 plus anything is that number. So that's why every time for sum we have to take 0, and for product we are taking 1. The next thing we are doing over here is we are asking the user to enter any number, and that we are storing it inside N. Then if you look at this block, the while loop, it is same like we did breaking a number. So this thing has to be same, because R is giving you the remainder and N is decrementing itself by dividing it by 10. So every time it's getting divided by 10, the number is decreasing the number of digits. So over here, what we are supposed to do is we are supposed to find the sum. So we write sum equals to sum plus. Now, what we have to add? We have to add the digit. And digit is stored in which variable? R. So sum equals to sum plus R. So this is how we do the program. Now, if you take this example 731, what will happen? The value of R will be 1, because 731 modulus 10 is 1. And the value of N will be 17. So S will be S plus 1. After that, the value of R will be 3. Then S is already 1. 1 plus 3 is 4. Then the value of R will become 7. So this thing we have already done in the video earlier. You can just check that if you have not understood that. And at the end, the value of R will be 7. 4 plus 7 is 11. And then the value of N becomes 0. The loop is over. After the loop is over, we display the sum of digits. So sum of digits equals to plus S. So plus S means the variable S has the value 11. So sum of digits equals to 11 will be the output. So I have used a very easy program because we have just started with the number programs. So later on we'll do with other programs as well. Thank you guys for watching my video. I hope you liked it. If you have any doubts, queries, anything, you can just mention that in the comment section given below. The program I have done over here is not complete. So I have done the complete program and I have given the link in the description below. You can check that out too. Very soon I will be coming back with part 2, where we are going to do the programs based on breaking a number. So till then, stay tuned, stay safe, stay at home. Thank you guys for watching my video. If you like my video, please hit the like button and don't forget to subscribe my channel, Accidental Teacher. Now for any reason, if you have to go outside, please don't forget to put this on.